Okay. Okay, then I think we are good to go. Yeah, good evening, everybody. I'm Philip, and I'll be telling you something about using the new Wayland protocol when programming client applications. First, a few words about me. I was participating in what? Okay. I was participating in Google Summer of Code last year as a student for the Cody project, and I implemented the Wayland backend that will be in Cody version 18, which is the next version. And yeah, with this talk, I want to share some of the experience I gained there with you. Like Lucas before me, this is actually my first time at FOSDEM and my first time giving a talk to such a big technical audience, so I am very grateful for the opportunity, and I'm very happy to be here. So about the talk just quickly, I'll give you an introduction to Wayland, but I'll not go very deeply into that, and I will be also not talking about Wayland from a client perspective, from a user perspective, and also not for motivation behind the Wayland design. Then I'll show you how the process works for getting a window on screen and showing something and getting some input done. And I'll give you some general hints for client development in practice, like how do you go about testing and debugging this stuff before coming to the conclusion. Due to the time constraints we have here, I initially applied for a 60-minute talk, but we have 20 minutes now. I will be not giving too many hands-on and in-depth examples, but I'll still give you the basics on Wayland. So, to start, the big picture of Wayland and X. So, to get some key terms out of the way, what actually is X? I mean, most of you probably know, or the question should rather be what is part of the X project. And actually, X is mostly X11, which is version 11 of the X protocol, which is a protocol for communication between graphical applications and a display server. And like, how many of you have used the phrase like, oh no, X crashed? Just put your hands up. Yeah, quite a few. And that is technically not what you should be saying, because X is a protocol, right? So what you are meaning is, of course, that the x.org server, which is the canonical server-side implementation of that X11 protocol, has crashed, which yeah used to happen from time to time. And that is actually similar to what Wayland is. It's like X11. It's a protocol that is intended to succeed X11, and it's not actually a server. It is also some supporting C libraries, such as the Wayland client, which I'll be getting into later. And part of the Wayland project is also FOSDEM, which is the reference server-side implementation. But it's not like on X, where we have the x.org server, which pretty much everyone is using. FOSDEM is really just for reference and for some specific use cases. All big desktop environments like GNOME and KDE, they have their own Wayland server. So, to sum up, Wayland is not a piece of software that you can run. So you cannot say Wayland has crashed. That just does not make any sense from a technical point of view. And it's also not quite like X11. So why isn't it? The key differences, just listing them up, Wayland servers, which you usually refer to as compositors, they do a lot of stuff actually. They combine the display server, the window management, and the compositing functions in one process, which used to be separate with X11. Which has been possible because of lots of work in the Linux kernel on getting the graphics drivers into the kernel and out of the x.org server. So Wayland is also, the scope of the protocol extends a bit beyond what X11 is doing. We are not just looking at like the desktop use case where we have Windows and stuff, but also other environments like in-vehicle infotainment, which Wayland also has protocols for. And perhaps the difference that people talk most about or notice most is that the design has more security inherently than X11 had. For example, there are no general purpose interfaces for interfacing with other windows, for example, manipulating other windows, stealing contents of other windows, or injecting input into other windows. And this is by design. But it's not like we want to forbid all the stuff that was possible on X11. It's just that you will have to be doing it differently. Because there should be protocols that support specific use cases and are not like the shotgun model that you have with X11, where just any client can do pretty much anything. And these use case specific protocols, they are also designed by the Wayland community, but they are just not there yet because nobody has put enough effort to support these specific use cases. And also the solutions that you end up could be radically different from what you would have done with X11 because the circumstances are different. Yeah, and last but not least, there's also less craft in the protocol because it was designed from the ground up. For example, there's no server-side drawing at all, and there's also no font configuration, no font rendering stuff. This is all done by the clients and not by the server. So if you're looking to implement a Wayland client, you have two basic options. Besides just saying, I'm just not doing Wayland, I will continue with X11 because there's a transition layer which is called X-Wayland, which works quite nice. But I guess you're here because you want to hear about what you would do with Wayland. You could go native, which is what this talk is all about. You just program for Wayland directly. It is an effort that is comparable to using Xlib or XCB for X if you've used that. But there are some differences. I mean, because Wayland has client-side decorations mostly, and this is which means that if you want to support windowed mode, you want to draw your application in a window, then you will also have to draw the window decorations, and not only that, you will also have to draw the buttons in the decorations, and you must react to button clicks, and you must support moving and resizing the window and showing the right cursor on resizing and all that stuff. This might become less relevant in the future because there's an effort going on to standardize server-side decorations on Wayland, kind of, but it's not there yet, and at the moment it's still a big problem if you want to have your application support windowed mode. So what my recommendation would be that in all cases that it's at all possible, you should be using toolkits, which is the second option. GTK, Qt, EFL, SDL, and GLFW, they all have quite good Wayland support, and you just have to do a lot less effort. The toolkits do all the heavy lifting for you, and you also get the benefit that your application will run on a lot of other platforms, and it will also run on X, because if you're doing a native Wayland application with no kind of fallback, then your application will just not be running on X11. Yeah. But I do realize that using toolkits might not be an option for everyone if you're doing very specialized software, or if you want to write the toolkit. So this is what this talk is about. Okay, after this introduction, a brief introduction of more in-depth look at the Wayland protocol, actually, how it works. It's object-oriented, which means that you create new objects via the protocol and then call methods on them, which are called requests, or you get events from the server. And every function call is associated with an object. There are no like raw function calls. The protocol is defined in XML files, which the main one is called Wayland.xml, which is shipped with Wayland. And there are some additional protocols for specific use cases, like the in-vehicle entertainment stuff. That is part of another repository that's called Wayland protocols. And from these XML files, then the C code that you use to interface with Wayland is actually generated. This is also modular, which means that the set of interfaces that is available is easily extendable. It's kind of similar to X11 protocol extensions. And yeah, the biggest difference that you will notice at first is that it's completely asynchronous and message-based, which means it's not really request response anymore. Requests are completely fire and forget, and you don't get you can't really ask the server for any state. The server will tell you when the state changes, and you have to remember the state in the client. Okay, some specific interfaces that you will have to use when you're using Wayland is firstly WL_display, which is just the singleton interface that represents the connection to a Wayland server, and you get that just when connecting to a Wayland socket. And the other one is WL_registry, which you derive from WL display, and then that in turn provides access to all other global objects and global interfaces that you will be using. So it is kind of the entry point for everything. And that's also what you see on the right side. You get the WL display, then you call get registry on that, get a registry, and then you get access to all those globals that are underneath. And what those globals are will actually vary depending on what compositor you're using and what environment you are using it in. Most of these globals are singletons, for example, WL compositor is singleton, and others, for example, WL output, which could be representing a physical monitor, will appear multiple times. If, for example, you have multiple monitors connected, you will get multiple WL output objects that will give you the details on those monitors. So how do we use the sum of those globals to actually get a window on screen? It's not that easy of a process, so I'll just give you the high-level overview and not go too much into the details. First, you use the compositor global that I've been briefly speaking about and use it to create a surface. And the surface is just the typical rectangular area of pixels that you can put some content in. But you can't. But if you just create a surface, then it won't be displayed, because all surfaces need a role, and exactly one role that tells the compositor what it should do with the surface and what kind of way it should use it and display it. And what you will use for that is, if you just want a regular window on a desktop, then there's an extension protocol for that that you should be using, and it's called xdg_shell. It's still unstable at the moment, and is part of the Wayland protocol repository that I mentioned before. But it's the de facto standard that you should be using. And the one that is in core Wayland, which is called WL_shell, it's effectively deprecated, and you shouldn't be really using it anymore. There's a stable version of XDG shell that's already there, but not many servers are supporting it yet. So for the moment, this is still your best bet. You should be using XDG shell version 6. And if it's ever replaced by the stable version, it's just a copy and paste job, and you just remove the set prefix, which means unstable, and remove the version at the end, and then you are good to go with the stable version. Yeah. So how do you use that? You get the global, the XDG shell global. You use that to get an XDG surface object for the surface that you have created, and then finally call get top level on the XDG surface. And this top level object is then the role of your surface. And top level in this case means just a top level window that the compositor will then put on screen. Yeah, not quite, because the compositor will not put it on screen unless you put some content into the window. So how do you get the content? There are, again, two possibilities. You can render on the GPU, or you can render on the CPU, roughly speaking. If you render on the GPU and use Vulkan or EGL, then you are pretty much covered, because that is quite easy to do. The interoperability is great, and you don't have to really set up much. If you use the CPU for rendering, then it's a bit more complicated, because you have to figure out how to get a shared memory buffer and how to share that with the compositor, which is what I just I'm indicating here. You create a buffer and attach that to the surface. And it's a bit more involved than the rendering on the GPU. And for rendering, you could use either you already have your own renderer. For example, when you are developing an OpenGL-based game, then you will just use that to render the game. Or for 2D drawing, you could use Cairo or the Skia project, which the Chromium guys have developed. Okay. That's it for the window. If you do all that, then you will actually have a window and screen. And you want some interactivity, probably. So it means, how do you get input? There's a concept called a seed, which is a group of input devices, a pointer, a keyboard, and a touch device. And each seed can have at most one of those devices. And you register for the global, then you take the seed, and these seeds can actually be hot plugged at runtime, so you should always be prepared that the seed appears or disappears. and your application should handle that and not just crash then, which would be very bad. And then via the seed, you can get access to the pointer, the keyboard, and the touch. And for the pointer, there's the special thing that you have to take care of setting the cursor. As soon as the pointer enters your window, you have to give the Wayland compositor a cursor that is an image that it has to use. But there is the Wayland client library which handles most of it and loads just the regular old Xcursor things. For the keyboard, then the server sends you just simple key events when something is pressed, but you have to decode them with xkb common, because the server will also send you the key map that the user is using. So you have to go through that to translate the keys to what actually was pressed. How do you use that stuff actually in C? Because I've not shown you any code, I guess. There's the C library, which is called libwayland client, and all the other stuff is currently built on top of that. So it's like xzb or xlib. And if you're coding in C, then you should be using that. There's not really an alternative. And you have to use the executable Wayland scanner for any extra protocols that you might be using from XML files to generate the C code to interface. If you want to integrate this into your event loop, then you should be taking care to use a proper API. So just see the documentation if you want to do that. And for starting out, I recommend downloading the source for FOSDEM, the reference compositor, and look at these files, simple.shm.c and simple.egl.c, which are just demo clients that are very minimal, but do enough that you can just have a window and get some input. So it's really the best way to start getting your hands dirty. If you want to use threads in your application, then it is supported by libwayland client, but you have to be careful and take some precautions, which are again available in the documentation. There are some bindings to other languages if C is not your thing. I've tried to list the ones that are most stable at the moment, which you can see here. And in the slides that you download, these are all links. You can just click on it if you're interested in that. But the state of maintenance varies between the bindings, and libwayland client is actually your best bet if you want just something stable. So now you have written your client, you want to actually test it, and either you are lucky and you are already using Wayland on your desktop, then you can just run your application. And if not, it's also not a problem, because you can run a Wayland compositor on top of X11 or on top of Wayland in nested mode, which is kind of like a Xavier if you've used that on X11. These are just it's just a list of compositors I would recommend you to test on with the recommended versions that you should be using and how to start them in nested mode. And with the environment variable Wayland_display, you can instruct your application to start on another Wayland display server. It's like the X11 display environment variable. So if you want to, if you run GNOME normally and want to test on another compositor like FOSDEM, then you can just start that in nested mode and start your application there. I would always advise you to test at least on FOSDEM, because it is the reference compositor and it's most strict about the protocol. And you might want to skip KDE and Enlightenment for the moment, because they don't have a stable released version that supports XDG shell version 6, as far as I know at the moment, but they are working on it. Very useful is setting the environment variable Wayland_debug to 1 when starting your application. Then you will just get on standard error or standard output, I think, just a trace of all API calls that you are doing on the Wayland socket, which is very useful. You see everything you send to the server, you see everything the server sends you back, and can look for problems and information. And if you want to just see what kind of globals and your compositor supports, you can use the Western info executable, which is a part of FOSDEM. But even though it's called Western info, you can actually use it with any compositor to just gather information on what kind of interfaces are available. Yeah, and since many compositors and also the Wayland project in itself are not that well established like X11 yet, if you encounter really weird stuff like while testing like this, then sometimes the bug is in the compositor and you have to be prepared for that. So, to conclude, there's a lot more to this. We've only barely scratched the surface here due to time constraints. I haven't talked about stuff like clipboard, drag and drop subsurfaces, or how to really use xdg_shell, because it's a lot more complicated than on that slide. And it also has more restrictions than using just X11. For example, if you maximize your window, then the compositor will exactly tell you how big your window is. And if you attach a buffer of any different size, then your connection will just be killed. So if you're not very careful while implementing that, then you're going to run into big problems. You have to design this in from the start, that you never attach a buffer of the wrong size. Yeah, you should be thinking twice before not using a toolkit, because it really helps a lot and saves a lot of effort. And for just some further resources you could be looking into, the project homepage of Wayland has the main protocol and the C API documentation. If you want to use some extra protocols, then these are documented just in the XML files. It's very human readable, I think. The blog of Pekka Palanen has some in-depth reviews of some technical aspects of Western and Wayland, which I highly recommend for reading. And if you have any specific questions or problems, then the Wayland community are very eager to help. You can just ask on the #Wayland IRC channel on Freenode or at the mailing list. And I also use that to great effect during my Summer of Code project. And I really want to thank these guys, because they have been really helpful. So you should not be shy to just ask if you have any questions. And again, in the slides, these are just links. So if any of that interests you, you can just download them and click on it. Okay, that's it from my side. Thank you for being here and listening to me. Do you have any questions? Yeah.
What is the actual protocol between Wayland client and the compositor?
Oh, yeah. Okay, the question was, what is the actual protocol between the Wayland client and server? It is a custom protocol, and the wire format is documented on the web page, and it basically just encodes the request that you send into numbers that are calculated from the XML description, and it serializes that and deserializes on the other side. But the documentation on that is very good if you want to look at the details. It's on the homepage.
And it's like X11 that can be based either on TCP or sockets or...
Okay, the question was whether it's like X11 due to socket support. Yeah, kind of. You usually use a Unix domain socket on Linux. But the difference to X is mostly that it's not as network transparent.
Okay.
So you usually can't just use that over a TCP socket, because you are sharing file descriptors via the socket. So you need to use a Unix socket. Okay. Yep.
The project, we just got some patches to add Wayland support. And one of the things that literally today I was looking at the patch and what confused me is a piece of code, like the protocol file generated from the XML 4C was submitted as part of the patch.
Yeah.
Is this normal, or should we be looking for some other library that integrates that provides this?
Okay. The question was that in some project, I think in them, sorry. What?
We got a patch for GNU.
For GNU. Okay, they got a patch for Wayland support, and in the patch they included the generated C code from Wayland Scanner. And the question was whether that is a good thing, I think, and it's not a good thing. You should always be generating the C code directly from the XML. The protocols are installed system-wide, or if you use custom ones, then you can ship them with your project. But you should not check them into source control, because they are generated. You should always be using Wayland Scanner to generate them. Okay. Any other questions? Okay, then that's it. Thank you.